Today we shall see sample run of UVM based test case in atssim simulator. I have taken one test case which will show us how various phases of UVM run. So this is a simple topology currently implemented in this test case. There is one top class and this top class instantiates two objects of class A, and each of these two objects of class A instantiate further two objects of class B and D. Let us see what is the structure of various classes in this test bench. So D class is extended from UVM component, and this has defined build phase, connect phase, end of elaboration phase, start of simulation phase. Then run phase is not defined here. Run phase is usually defined with the task, run phase task, and then post run phase there are three phases: extract phase, check phase, and report phase. So in this class B, we have not defined run phase. Now take a look at class B. Class B has one variable. It's a random variable named as delay. Then this has also got defined build phase, connect phase, end of elaboration phase, start of simulation phase, and post run phase there are three phases: extract, check, and report. So first time we have defined run phase task, and there is one display, that is the start of run phase, and after the delay time units it will display end of run phase. Now let us say the sub phases of run phase which run in parallel with the run phase, and these phases are the reset phase, configure phase, main phase, and shutdown phase. And each of these phases have got pre and post sub phases. One important thing is these sub phases, reset, configure, main, and shutdown, they run in sequence. So I will show you how these phases are run through a diagram. Let us take a look of this phase diagram for UVM phases. So at the top you can see the build phase which is defined in terms of function. So build phases are the build phase, connect phase, end of elaboration phase, and then come the run phase. So start of simulation is a function, it's not the task, and after this start the run phase which is defined in terms of the task. Now we can see these sub phases of the run phase. These are the pre-reset, reset, post-reset, pre-configure, configure, post-configure, pre-main, main, post-main, pre-shutdown, shutdown, post-shutdown, and they are joining back to the extract phase here. So here you can see one important thing, that this all 12 phases are in sequence, and this run phase and these 12 phases are in parallel. So this is the topology. How does the phase work in UVM? Various phases work this way in UVM. Once the run phase is complete, extract phase, check phase and report. Three phases are there. Now we go back to our UVM example. I have raised objection for pre-reset phase and then dropped it after the completion of pre-reset phase. I have taken a sample construct here for loop which is running 10 times and showing the value of I and delayed by 5 time units. Then I have defined the reset phase, post reset phase, pre-configure and so on. One more thing I have done here, in the main phase I have again raised the objection and this displays the start main phase and the time unit, and then I have provided a delay. I have again given a for loop here and the delay provided here is twice the value of I, and again it is showing the displaying end of main phase, and I am dropping objection here. Now remaining sub phases of the run phase are not raising any objection. So we have to remember one thing, that whenever the objection is raised, that particular phase will wait for all the parallel phases to complete until the dropping of the objection. Now we come to see the class A. Class A has instantiated two objects, one of class B, B1, another of class D, D1. Here again we have defined the random variable delay. Now within the construct of this, B1 and D1 are instantiated, and let us see the same build phase, connect phase, all are defined here. Run phase does not have any objection raised here, neither any of the sub phases of the run phase like pre, reset, reset and so on. This is the class A. Now look at this. This is simply class AA. This is acting as a envelope or the wrapper, and here the class A object A is defined, and within new function this is created. Now we look at this top class. As I told, in the top class, two objects A1 and A2 of type class AA are defined and created here in the new function. Within the build phase, connect phase are same. None of them they are almost the same, since these are the functions, so they cannot include any delay within them. Now the run phase of this top class has the objection raised, and this is ending after 500 nanosecond. So we can presume the overall running of the test case will be around 500 nanosecond. Reason is, in the previous classes we have defined delay that is of 8 bit, so it cannot assume any value more than 255. time units. Now the remaining tasks, these are the subtasks of the run phase. They also don't have any objection raised. And finally, in this, I have not defined any. I think extract phase and the report phases are already defined here, right? In the starting. So here the top object is instantiated T. T is randomized here, and then run test is called here in this initial block. Now let us see how do we run it on atssim. So let us see how does it run. So I have given, let us give the command exe atsm. So I have defined all the command line options in the file option uvm.txt. I will show you the contents of this file in a while now. So this is the command which I have to give to see the run of this test case. Let us see what are the contents of option uvm.txt file. So these are commented, but this is the first option which indicates that include directory UVM home and then src. So this contains all the required macro files and UVM based files which may be included within the design. NI stands for non-interactive because I'm not running this in an interactive mode. Option atssim, that is n times end simulation time. So I have limited the end of simulation time up to 10,000 time units. So currently I haven't defined any time scale. So this will be by default in nanoseconds. So 10,000 nanosecond will be the end time. I don't want to generate any database for the design or current test bench. So I have defined a switch no dbf, because usually if you give don't give this switch, it generates the database file for this complete test environment, which we don't need right now. So here the the name of top is I think TB, or let me see the name of the top module. This is my top. Oh, this module, yeah, this is the top. This will act as a top. So this is my option file, command line option file. Now I'm going to give run for this test case. Let us see how it executes. Design is compiled. Now elaboration is complete and test run has started. So build phase, it's showing the execution of the build phase. So execution of top, then both the objects within the top A1, A2, and within A1, A2 there is a another object A, and each of A is containing B1 and B1. So we can see start of uh, then connect phase, then end of simulation, end of elaboration, then end of simulation, sorry, and then you can see here start of run phase, then start pre-reset task. So reset task, I have placed the objection, so this will run until the end of pre-reset task, and then one by one all the phases are running. Then start of pre-shutdown, start of shutdown, start of post shutdown, then end of post shutdown, and end of run phase. Now we can see there are randomized delays for various run phases, those are shown here. Then run phase are complete, moving to the extract, check and report phase. This is the complete execution of my test case, which has shown the running of various phases of UVM. Let us take once again the look of and the sequence of all the UVM test phases. First is the build, second is connect, then end of elaboration. For each and every component which is extended from UVM component and which is the part of the verification environment. So this will be automatically done. Remember, all of these phases in various components run in parallel. So start of simulation, then start of run phase. I had raised objection for pre-reset task. So it has run it completely from up till the 50 nanoseconds. Then end of pre-reset task. Now start of reset, all are done in one go, but these are not complete. Reason is none of them have got objection raised, so those are prematurely killed. Now we can see start of post reset, pre-configure, configure, post configure, pre-main, then main. Then I had given objection raised in main phase also. So I have raised objection in main phase also. So therefore it is waiting this main phase also to complete. Once it is complete, end of run phase, then start of post main, pre-shutdown, then shutdown, and post shutdown, then end of post shutdown, and finally end of run phase. Then after the run phase, it will cover extract, check and report phase.